Welcome. Question number 26, 27, T sections. See, last class, first we considered this way T section. Of course, one question, different offsets. Then, see, little difference. Then, symmetrical T. Then I took even inverted T also. I think 4 questions are solved, inverted T. Now, same T section, turn this way. See, once turn this way, flange and web here. Turned other way, flange and web here. What I have done is, this question I made, see, not symmetric. See, this offset are not equal. Deliberately, to get more work. This question, offsets are equal. That is sufficient. Furthermore, examples, here I will not give, exercises will be there. Some of them I will give in the notes only. Start first. Question 26. Both the questions find moment of inertia about centroidal axis. All dimensions millimeter. Usual thing. See, first right here. I about, first of all I should not tell. What is required you write? Moment of inertia about centroidal axis, IXX, IYY. So, centroid G you have to locate. That all statement, it is told so many times earlier. Write everything. So, first to locate centroid G. See, right here. To locate centroid G. Start. Take O here. OX, OY. X bar this way, Y bar this way. See, 200 by 40. 200 is not here. It is somewhere there. And 30 by 180. This offset is 75. Be careful. This is 75. When that is 75, total 200. From 200, subtract 75, subtract 30, you will get 95 here. So, smaller offset, bigger offset. Now, when you mark component centroid, see here, this way midpoint, 40 means 20 and 20, no problem. This way, see, this is 200. It will be at 100 from here. 100 means 95, so slightly more. But to this level it is 90. Centroid of this level is 95 plus another 15, 110. Oh no, little below this level. See, this G1 is little below G2. Okay, then second one, this way center G2. Where is it? See, 95 plus another 15. It will come here. And this way, it is exactly center of 180. These all you should make note. Start X bar. 1, 2. A1, X1. How much X1? A1 I won't explain. A1 is here. X1 is 40 by 2. A2 into X2. 40 plus half of 220. No, hurry. 40 plus half of 180. 220 is full. Full 220. How I got? See, 180 plus 40. Totally 220. This is only 180. Half of 180. Divide by A1 plus A2. X bar will come. Y bar. A1, Y1. Y1. Half of, how much? 200. Y2. 95 plus half of 30. So you get X bar, Y bar. Once you get X bar, Y bar, immediately locate the axis. See, from O to right side by 64.328. See, this is 40. Little more. See, exact scale is not required. See, what you do is, see, this is YY. When you come here, don't disturb this one. See, when you get other dimensions here, what you have to do? Jump. Jump here. Okay. This is your X bar. Don't have to write. If you want, write X bar 64.328. You write if you want 328. Okay, 1 minute. 64.328. I won't write. If you write X bar, once it is 64.328, from here 220 minus 64.328 is from here. It will be, see, from this extreme edge. From this extreme edge. If you want this distance, you require it. This distance is from 220, subtract it. 155.672. 672. 55, correcta? 65, 65, 55, 65. Yes, correct. 65, 55 is 120. Okay, now y bar. How much you got? 104.03. Y bar. From here, 104.03 means, see, this centroid is at half of 200, is 100. Little more than 100, see. But is it above this or below this? Check it. See, from here, 104.03. These are all small points. You should be careful. See, from here up to here is 100. Why 100? Total 200. So it is slightly above. But up to here is 95 plus 15. 95 plus 15 is 110. So your xx will come above G1 but below G2. See, these small points, you should be careful. See, this little, sorry, out of scale. Okay, when I go there, this is your xx axis. Then x distance, see, from here to xx, red color, is 104.030. So from the top extreme edge, this will be, how much it is? 95 point, I already calculated, 95.970. Okay. This is centroid G for the entire cross section. First of all, same question we solved earlier also, but at that time, this distance was not 75 in the centroid. Sometime I take same question. Sometime I will do one thing, I will take a separate question, just like that. Okay. Now, x bar, y bar I will remove. Now correctly calculate moment of inertia. Start. As usual, right here, somewhere in, right below, anywhere, calculation of moment of inertia I about xx and yy. See, right here, calculation of, these all I am dictating, calculation of ixx and iyy, right? By parallel axis theorem, I about any axis equal to, I am writing 100 time now, ig plus a into h square. H always is red color. Why? To understand. A into h square. What is the meaning of each term? I think told more than 100 times. Difficulty means, suppose I am not telling too much explanation, somebody will come tell, not fully explained. See lecture number 55. I warned everybody there. Okay, start. Now, systematic way, ixx. I will start from here. Okay, sufficient space. ixx. Correctly see. Start. Come to centroid. Axis passing to centroid parallel to xx. See this axis. 40 into 200 cube by 12. 40 into, see, this is very carefully you should write, by 12 is your Ig plus area. 40 into 200 is the area into, from centroid G1 to xx axis. See, I will not tell. Horizontal axis means vertical distance. Maybe telling infinite times now. See, this distance square. 104.03. See, from here to here is 104.03. Subtract half of 200. 200 by 2 whole square. This is I about xx of figure number 1. Come to figure number 2. First about, see, its own centroid of axis here. Here. 180 into 30 cube by 12. Space is there? Yes, I think space is there. Bracket I will use. I'll do one thing now to save the time. This side I'll push it now. Into bracket here, how much? 104.030 minus, I'll put one below the one, 200 by 2 whole square. Okay, to save the space, you write horizontally. Okay, over. Plus, for this one, I about its own axis. 180 into 30 cube by 12. 30 cube divided by 12 is Ig plus area. 180 into 30 is the area into, see, this distance square. That is, see, from here to centroid is 95.970. From the top edge up to what? XX axis. How much it is? 95.970. But we want what? We want from here to here. So 95.970 from this full distance, subtract 75. See, subtract 75 and also subtract half of 30. Subtract half of 30. That whole square, close the bracket. Over. I think further explanation is not required. Why? We reach a stage where these are all told more than 30, 40, 50 times. People who are serious will understand. Okay, over. IXX over. Now come to IYY. I about YY. Start. YY we want. Come to G1. Axis passing through G1 parallel to YY is see here. 200 into 40 cube by 12. 200 into 40 cube by 12 is IG plus area. 200 into 40 is the area into from centroid G1 to YY. See, this distance square is 64.328, so crystal clear. 64.328. From that one, subtract half of 40. 40 by 2 whole square. Over. Come to second part. I about YY. First about its own centroidal axis. See, these questions, what it will do? It will give you more and more grip. Your knowledge level, control on subject will increase. That's why I am solving so many questions. You show one place where so many questions are solved. Some 5-6 questions they will solve and tell chapter is over. Okay, start. I about this axis. 30 into 180 cube by 12. 30 into 180 cube divided by 12 is IG plus area 30 into 180 into, see, from centroid G2 to YY, this distance square, that distance is 155.672 minus the 155.672 minus from here to here is exactly 180 by 2 minus 180 by 2 whole square over. Calculate the answer. Yes. You get the answer. Calculate both. Question is over. Which one? Question number 26 over. Now come to question number 27. Now 27, some statement you have to write before you start. See. I write here. See. Question 27. See, solution for question number 27. It is a T section, see, given like this. This all I am rubbing now, this way. See, this way, this way. Now, this width is 190, right here. This is 190. This thickness is 10. Now, these two offsets are not given. When it is not given, understood that this offset and this offset both are same. How much? Equal to 190 minus 10 divided by 2. See, 190 minus 10 divided by 2. How much not required? Or these are equal. Then write, therefore, this T section, that current T section is symmetrical about, see, XX axis, not YY. See, how much above, below. If this is XX here, this distance and this distance are 190 by 2 and this also 190 by 2. But YY axis, you have to look. So YY, we don't know. So to locate YY, you require X bar. X bar from a reference vertical axis. Now origin wall not required. So now that statement you write and then start. Need sketch right now. Need sketch. See, 10 thickness. Thickness is 10. Little down. Thickness 10. And see, total is 225 given. This is 12. So this distance will be lesser. You have to calculate it. See, it will come this way. Space problem is there? No. No space problem. Okay, this way. Then how much it is? Around 198, 180, 80, 80, 90, 90, 90, this is around more, see, little more, okay. Exact scale is not required. Both are equal offsets, see, equal offsets. This is 90, a little more, okay, little more. Thickness how much? Thickness is 12. This is 10 thickness, this is 12 thickness. See, okay, little bigger, okay, correct? Okay, now, okay, correct, okay, start. Now, dimensions, see here. Anywhere you can write, this is 10. Now here, from here to here is, from 225 subtract 12. From 225 subtract 12. 225 minus 12 is 213. This is 213. This is how much? That is 12. So overall, full from here to here, this is how much? That is 225. I just checked the camera once actually. I have gone little further more. If number is not visible, it slightly shift the camera. No problem. Okay, 225. That always I do. Okay, then this way is over. This width is how much? This width is 190. That's all, right? Understood. These two are equal. Everything is over. So therefore, I told you, see, divide into two parts. So how to divide? This way. Divide two parts. Any one you can take one, other one you can take two. Left to your choice. I will take this as 1 and this as 2. Okay, then you require, I told you, see, XX will come here. Only YY you have to locate. So take reference axis here. This time origin wall not required. Say AB, my favorite AB. From AB you consider X this way. Okay, start. Centroid G1 here. Centroid G2 at the same level. Why? Symmetrical. This is because symmetrical about XX. This is G2. Then first calculate. X bar from AB, how direction? X bar is to right side, equal to, write the formula, A1 x1, A2 x2 divided by total area A1 plus A2, then write equal to A1 213 into 10, 213 into 10 into, from here to centroid is 213 by 2, 213 by 2 plus 190 into 12, 190 into 12 into 213 plus 12 by 2, 213 plus 12 by 2, or you can write 225 minus 12 by 2, anything will do. Total divided by A1 plus A2, 213 into 10 plus 190 into 12. You will get the X bar value. Calculate X bar. I will calculate now because I have not calculated. I am calculating now. Okay, no problem. 213 into 10 into 213 by 2 plus 190 into 12 into 213 plus 6 divided by bracket 213 into 10 plus 190 into 12. 164.663. 164 answer. 164.663. 164.663 millimeter. Therefore, that's all. Okay. From here, see how much you got? 164.663 means from here to center is half of 213. That is around 106.5. more, not up to here. 164 means, see, it will become somewhere here, somewhere nearby here. See. Exact scale are not required. This is the y axis. So this distance is 164.663. You write if you want x bar value. Then write also from this side. How much? From 225 subtract. From 225 subtract 164.663 is 60.337. 60.337. But what usually I do is, I want to cross check now. 190 into 12 into 6 plus 213 into 10 into 225 minus 213 divided by 2 divided by bracket 213 into 10 plus 190 into 12. 60.337, correct? Yes, 60 point. I found x bar from that side. I got 60.337. Perfectly correct now. Okay. Now, xx, yy. Where is xx? No calculation. I told. Directly mark to centroid xx axis. See, it will pass through centroid of both xx axis. Okay, start. Now, I will remove this calculation. I will go for moment of inertia calculation. Today class, it was smaller class. I had a lot of work today and went outside and spent a lot of time. Therefore, feeling little tired. So what I will do is, I will just give this one. I told channel I will do. Channel I will do next class. Okay, class around 30 minutes today. Okay, now that's what people usually want. Now, calculation of moment of inertia. Calculation of I about xx and I about yy. Okay. Start. Right, usual story. I about any axis equal to ig plus a square. If you are lazy, if you don't write, you are losing. What all I told earlier, you should follow. So, start. I about xx. I see one more thing, remember. I told when you find moment of inertia about any axis, when you consider a component, if the centroid of the component, if it lies in the axis, when you put ig plus a square, h becomes 0, so only ig, already told 100 times. So, start. First I about its own axis. See, its own axis parallel to x-axis. You can see there is coinciding with the x-axis. How much? 213 into 10 cube divided by 12 plus 213 into 10 is the area into, see, from centroid to x-axis, perpendicular square. Where is perpendicular? 0 square over. Suppose somebody laws are not clear. Not clear means study somewhere else. Plus, I should be harsh sometimes. I about xx for this one. First about its own centroidal axis. 12 into 190 cube by 12. 12 into 190 cube by 12 Ig plus area. 12 into 190 is the area into centroid G2 lies in x-axis. So no distance this way, because horizontal axis means vertical distance is not there. 0 square. Calculate the answer. Okay, now I about yy. 27. Start. Now you require first I about its own centroidal axis. 10 into 213 cube by 12. Ig plus area. 10 into 213 is the area into from centroid to yy. See, this from centroid G1 to yy, this distance square, this is G1, okay, G1. Okay. From here to here, see, this distance square is 164.663. Subtract, this distance is 213 by 2 minus 213 by 2 whole square over. This is Ig plus a square. One term over, first term is over, second one. For this one, I about yy you require. First about, see, its own centroidal axis parallel to our yy. 190 into 12 cube by 12. 190 into 12 cube by 12 plus 190 into 12 is the area into from centroid to YY this distance square, that is 60.337 minus half of 12. See, from here to here is this distance minus 12 by 2, half of 12 whole square. Calculate the answer. Question 27 also over. I will give one small exercise for you now. Now see, we have to work out the question with the answer. 26 over, 27 over. I will change the question now. 28. Simple for you to answer. Briefly I will tell. 28. I will forget that one. Same, turn T section. 28 question. See, I usually forget the number very fast. Okay. Question 28. An exercise for you. 28, somewhat exercise. See, I will put T section like this. Very simple, see now, this way. Symmetrical this time. This way. This way T section. Or I will do one thing. Just to understand, wait. I will consider a T section which is available in IS handbook. I will consider which is available in IS handbook. Provided in the handbook, I don't have handbook. I got one Xerox copy. There, if T sections are there, I will write. Otherwise, I will continue. 1 minute, I will check it. One exercise for you. Yes, I got it. Find radius of gyration about centroidal axis. See, 180, total 250, 9.2 and 14.1. I will tell you why I took fractional values little later. This is a given T section. These two are equal. First try statement. They are asked to find radius of gyration about centroidal axis. Again, I told earlier. Again and again, same thing I am repeating. They want to find what? Radius of gyration R about XX and R about YY. Everything is very thoroughly explained. You should know RXX equal to root of IXX divided by A. RYY is root of IYY divided by A. Therefore, if you want radius of gyration, first you have to find moment of inertia and also you require area. Okay, make a note. So once again, question is to find moment of inertia only. Then lastly, root I by A will give R. Every statement right. Then divide into parts. See, I will take this as part 1 and part 2. This I will take part 1. This I will take part 2. Centroid is here. Centroid is here. Okay, now see, 180 by 14.1. From 250 total, subtract 14.1, you get 235.9. The thickness given 9 point. Now, this is exercise for you. Therefore, I will dictate, I won't write. Area. This I will write. 180 into 14.1 plus 235.9 into 9.2. Area, I got 4708. X bar from where? See, you find X bar from this line. I already told you. First make a note. Before that, this is symmetrical about XX axis. YY you have to locate. See, again you are right. We have to locate YY. To look, XX is symmetrical. See, XX is symmetrical. To locate YY axis, X bar required. Calculate. A1, X1, A2, X2. A1, 14.1 into 180 into 14.1 by 2, G1, G2, once again, same statement, G1, G2, plus 235.9 into 9.2 into 14.1 plus half of 235.9 divided by total area, already you got it, 4708, X bar will come 64.673 millimeter. Locate. 64.673 means, see, somewhere here. Anybody on the road will agree. Y axis here. Y axis here. This distance is 64.673 millimeter. Then from other side calculate. You may require it. That is total 250. From 250 subtract 64.673 is 185.327. 185.327. Okay, write all this one. Okay, now write. Start. XX directly mark to centroid. See, passing to centroid, directly mark XX. You write there. XX is axis of symmetry. If this is 180, both are 90-90. You write if you want. Okay, start. Now, I about XX. I will not write. I will dictate. I about its own axis. 14.1 into 180 cube by 12 plus area into 0 square, and for this one, I about its own axis. 235.9 into 9.2 cube by 12 plus area into 0 square, you will get IXX. I wrote the answer here. Exercise for you. IYY. First about its own centroidal axis. This axis. 180 into 14, you should write everything. 180 into 14.1 cube by 12 plus area into, see, this distance square. That distance square is 64.673 minus 14.1 by 2 whole square. Then I about, first of all, the exercise question I should not explain. I about its own axis. 9.2 into 235.9 cube divided by 12 plus area into this distance square is 185.327 minus half of 235.9. You will get 6.868 10 to the power 6. That is what IXX is. IXX is this one. Yes, correct. IYY is more. Something wrong. 1 minute. Something is wrong. IYY is more. IXX more. IXX is more. No, not possible. I think I interchanged, calculation, most probably. Okay, 1 minute. I will pause the recording and check it. I think I entered wrong value. Not wrong value. XX I entered YY. YY I entered XX, I think. I'll check it. 1 minute. You wait. Yes, that is what happened. See, somebody will ask, sir, how you know that IXX is lesser, IYY more? By looking at the section only, I can make out it has got high moment of inertia about YY and low moment of inertia about XX. By looking only, I can make out. Okay, leave it. Okay, I interchange. See, same answer. Interchange here also. So we got IXX, IYY. Then calculate RXX, RYY. Now calculate RXX. Root of IXX by A, 38.194, RYY, root of IYY by A, calculate. If you cannot calculate, leave it. Okay, now, question is over. I told you exercise. So what I told is actually unnecessary. I should have just given the question and answer. But now, make a note. This T section is actually a standard T section, roll T section, where it is not rectangle. See, slight tapering is there. See, the T section is actually not that way. It is actually, see, this way, T section. Okay. Now, that T section, what I took is from IS handbook, its name is ISST 250. This is for those who are interested in steel structures. ISST 250. What is ISST? All you worry later. Now, in the handbook properties given, the width of flange they told 180 millimeter, and thickness of this flange they told 14.1, thickness of web they told 9.2, and total area they told 4775 mm square. Then YY is symmetry axis. XX you have to locate. Centroidal distance of XX from here they told where 64 millimeter. Then they told I about XX, how much? 27.744 10 to the power 6. I about YY 5.32 10 to the power 6. Then they told RXX RYY. Now check the answer here. Area. See. But the little difference will come because here we take rectangle. Actually curvature is there. So there curvature is considered, little more area is there. Okay, therefore you will get slightly lesser area. See, they told area 4775. We got 4708. Okay, reasonable. They told 47.75 centimeter square. It is 47.08 centimeter square. Okay, done. Area over. Then, see, one more important. Handbook, it is printed like this. But when I gave the question, I turned here. So, I turned here, see. Therefore, this XX, you should write here. What XX I marked here is YY there. And what YY I marked here is XX there. Be careful. So, this CXX is this distance, 64.673. They told 64. Okay. 0.673 millimeter is not a big issue. No, we are helpless. Then they told, see, I about XX is 27.744. That IXX is IYY. Yes, 26.45 you got. They told 27.7. Very minute difference. Okay. And IYY they told 5.32. But that IYY is IXX. It is 6.86. Actually, I think handbook made a mistake. Because I will not make the mistake. I checked once again. Handbook made a mistake. There is a misprint here. I think it is not 5.32. It is actually maybe 6.32. I think they made a mistake. Anyway, I am not responsible. Maybe they are given a correction later somewhere that so and so property IYY, instead of reading 5.32, you read some other thing, 6 point something, they would have given. Okay, then they told RXX is 76.2. Their RXX is your RYY. See, 74.954. Two difference in 78 is no, because that much is there. And they took a wrong IYY. They told RYY 33.4, but we got 38 because this answer given in the handbook is wrong, I am sure. Because so many rolled sections I considered by dividing into parts. Everywhere, minute difference. When such a difference is not coming, everything is tallying, how IYY can change? So I am not responsible because handbook made a mistake. See, I will not make the mistake, that's sure. Okay, now you do one thing. It is only a note, others all leave it. Don't bother. Those who are interested in steel structures, study this one. Otherwise, you solve the question as exercise and get the answer. Okay. Thank you. Next time we will meet. Next time I will do important one, channel sections.